Ever wondered what happens when you combine the most powerful light beams ever made with actual rocket science? Space lasers aren't just sci-fi anymore. They're measuring ice caps, zapping space junk, and might even beam Netflix to Mars. Back in 1917, Einstein had this wild idea about light particles getting super excited and multiplying themselves. Everyone thought he was nuts. But then in 1960, this scientist named Theodore Maiman built something that looked like a fancy flashlight with a ruby crystal inside. When he zapped it with intense light, boom, the world's first laser beam shot out. It was like turning light into a super-focused beam of awesome. The newspapers went crazy, calling it a death ray. But my man knew better. He'd just created the foundation for everything from barcode scanners to Blu-ray players. The best part? He did it all in a tiny lab, proving sometimes the biggest breakthroughs come in small packages. Here's the cool thing about space lasers. They're basically super accurate measuring tools. NASA and other space agencies shoot these incredibly precise laser beams at satellites, the Moon, and even Mars. When the light bounces back, they can measure distances down to the millimeter. It's like using a cosmic tape measure. They track how ice caps are melting, spot tiny shifts in tectonic plates, and even keep tabs on how much space junk is floating around Earth. Remember those GPS directions you used this morning? They're extra accurate thanks to laser measurements keeping all those satellites in perfect sync. And the best part? These lasers are so powerful they can hit a quarter on the Moon, from Earth. Here's a scary thought. There are millions of pieces of space junk zooming around Earth at 17,500 mph. Even a tiny paint chip at that speed hits like a hand grenade. But lasers are our cosmic traffic cops. Ground stations shoot precise laser pulses at debris as small as a marble. By measuring how long the light takes to bounce back, we can track these speedy space bullets and warn satellites to scoot out of the way. It's like a giant game of dodgeball, except instead of rubber balls, we're avoiding defunct satellites and lost astronaut tools. The coolest part? Some scientists want to use high-powered lasers to actually push space junk into Earth's atmosphere where it'll burn up. Talk about taking out the trash. Ever tried sending a text from Mars? With regular radio waves, it'd take 20 minutes just to say LOL. That's why NASA's cooking up something way cooler. Laser internet. By shooting data through space as laser beams, we can beam information 10 to 100 times faster than old-school radio. NASA already tested this by zapping an HD cat video from the Moon, because of course they did. But here's the real kicker. Lasers could let astronauts on Mars stream their favorite shows, video chat with Earth, and maybe even play online games with a slight 20-minute ping, but hey, it's Mars. The tech's called optical communications, and it's basically fiber optic internet without the fiber. Just pure light zooming through space at, well, the speed of light. Let's talk about space laser wins and fails, because boy do we have some stories. Remember Lady? This lunar probe shot a laser beam from the Moon to Earth in 2013, sending data at 622 megabits per second. Fast enough to download a full HD movie in minutes. Pretty sweet. But then there's the IceSat-1 satellite. It was measuring Earth's ice caps perfectly until its lasers started failing one by one like Christmas lights. The engineers' solution? They made IceSat-2 with 6 lasers instead of 1, because if you're going to fail with backup lasers. My favorite success has to be Japan's Hayabusa 2 mission, which literally shot a laser at an asteroid to study what it's made of. Though let's not forget the time scientists tried to use lasers to contact aliens in the 70s. Spoiler alert, E.T. didn't phone home. Let me blow your mind with this one. IceSat-2 splits its laser into 6 beams, fires 10,000 pulses every second, and can measure ice thickness with the precision of a pencil width. From 300 miles up in space, it's tracking how our ice caps change by mere inches. That's like standing on the Empire State Building and measuring the thickness of a pizza slice in Times Square. The data it sends back is helping us understand exactly how fast ice is melting, where it's happening, and what that means for coastal cities. But here's the really wild part. This space laser is so precise, It can even detect individual photons bouncing back from Earth. It's basically playing ping pong with light particles. Let's get real about space lasers as weapons. They're not quite ready for their Star Wars moment. Sure, the idea sounds awesome, satellites with laser cannons zapping threats from orbit. But physics keeps throwing shade at our space laser dreams. Here's the deal. Building a laser powerful enough to do damage needs massive amounts of energy. We're talking enough juice to power a small city, and that's just the start of our problems. The laser beam spreads out over long distances, making it about as threatening as a disco light by the time it reaches its target. Plus, our atmosphere loves messing with laser beams, bending and scattering them like a cosmic prankster. For now, military lasers are staying firmly on the ground, where they're actually pretty good at smaller jobs like taking down drones. You might think finding planets in space is like searching for cosmic needles in a haystack, and you'd be right, but lasers make it way easier. Scientists hook up super-precise laser combs to their telescopes, creating what's basically a cosmic ruler. These laser combs help spot the tiny wobbles stars make when planets tug on them. Imagine trying to see a fly making a cruise ship wiggle. Even cooler. When we catch light from far-off planets, we split it up with lasers to create a rainbow that tells us what these worlds are made of. It's like doing chemistry homework across light years. Some astronomers have even detected water vapor on planets 12 quadrillion miles away. Talk about a long-distance relationship. Okay, this might sound totally bonkers, but we could actually shoot tiny spacecraft across space using massive laser arrays. Here's how it works. Imagine a super powerful laser beam hitting a special sail on a spacecraft, kind of like wind pushing a sailboat, but with light instead of air. The coolest part, these light-powered ships could reach 20% the speed of light. That's fast enough to zip to Mars in days instead of months. Scientists at Breakthrough Starshot are already working on sending tiny probes to Alpha Centauri using this tech. Sure, we need to figure out how to build laser arrays the size of small cities first, but hey, dream big or go home, right? Ready for some seriously cool future tech? Scientists are cooking up space lasers that'll make today's tech look like toys. They're designing laser systems that can vaporize space junk instead of just tracking it. Imagine a cosmic vacuum cleaner zapping away dangerous debris. But that's just the start. On the moon, powerful lasers could melt moon dust into landing pads and roads, basically 3D printing a lunar base. And get this, there's a wild plan to use giant laser arrays on Earth to power spacecraft anywhere in the solar system, like a cosmic charging network. It's like building a galactic highway system, powered by light. Thanks for joining me on this laser-powered journey through space. If you enjoyed learning about these incredible light beams, smash that like button and subscribe for more mind-blowing space tech. Share with your friends. Let's spread some cosmic knowledge.